Okay. So part of the problem that you might have is knowing what to do and when to do it. Okay, so that's one of the things that you want to pay attention to while we're going through this. Because, like, identify the points of discontinuity. If you don't know what that means, then how are you supposed to find the right answer? So the points of discontinuity are where we have breaks in our graph. Breaks are holes in vertical asymptotes, which that is what a discontinuity is. It's a break in our graph, or in other words, it's where we get an error on our table of values. So one way we could actually kind of, I don't want to say cheat, it's not technically cheating, but a different way of doing this is to graph it and look at your table of values for where there are errors. And that would give you the points of discontinuity. What was your question, Carrie?
I was going to ask if you could just plug that into y equals.
Yeah, you can just plug this into y equals and then go to the table of values, and there should be two places where it tells you there's an error, and that's our two answers. If you wanted to do it algebraically, we would set the bottom equal to 0 and solve, which means I would have to factor. Yeah, -3, and go to mode and change it to function mode. FUNC. Make sure you spell out all 4 letters and don't stop halfway. If your calculator is messed up whenever you go to y equals, that's because one of my other classes is doing weird graphing things. So this is the mode you want to be in. Yes, in func mode. So +3 and +4 are the issues. So that's our points of discontinuity, are at x equals 3 and x equals 4. And so if we graphed it on our calculator, you'd go to the table of values, and at 3 and at 4, both of those should say error for your y value.
Wait, why don't you factor the top?
Because we don't need to. We could factor the top, but we just don't have to. So it'd be more work for us to factor the top. Other questions on number 1? Yes, Carrie?
Sorry. So they said on all these we're only factoring the bottom.
No, only on this one are we only factoring the bottom. Okay, on any of the other ones, you're going to factor the top and the bottom. Okay, but if it just asks you for the point, and I could factor the top, but it's not going to change anything. I would take out a 2 and get this, and this goes to x minus 3, x minus 1. The bottom, like, was x minus 3, x minus 4. Like, so even if I factor the top, what good did that do? I still have 2 things on the bottom. This is a hole because it crosses out, but I still have something happening at 3, and I still have something happening at 4. So if you factor both of them, that's fine. Just if it cancels out, that doesn't mean that 3 is not really there. 3 still has to be there. Okay? Okay. Number 2. Since there is a fraction on one side and a fraction on the other, we can cross multiply. So I'm going to do 2x plus 3 times 2, which means I need some parentheses. That equals 3 times x plus 1. So I have to distribute and then solve my equation. So since there's not an x squared, I just need to get my x's on one side and my numbers on the other.
Are you recording our class?
So x equals -3. If I come back and check up here, -3 plus 1, that's not 0. So this really is an answer. Okay, remember if we plug it in and we get 0 on the bottom, it's not really an answer. Any questions on that one? Cross multiplying should be pretty easy. It's when we can't cross multiply that it gets a little trickier. So I know I can't cross multiply because I have too many fractions. So I need to think about what a common denominator for all of these fractions would be. And to do that, I need to factor the bottom of my fraction here. -5, -3. And so what I'm going to do, and there are different ways of doing this, but essentially they all work out to get me the same thing. I want to multiply by my common denominator, which has to have x minus 5, because all of them have x minus 5, but also has to have x minus 3, because this fraction has x minus 3 over 1. When I do this, when I distribute to this first fraction, it has an x minus 5 on bottom. Here's an x minus 5 on top. Those cancel each other out, so that I just have to do 1 times what is left over, which is x minus 3. And 1 times x minus 3, I don't need parentheses because it's just x minus 3. Maybe 3. 2 or 3. Okay. X minus 5 and x minus 5 cancel out on the second fraction also, but this time we have 3 on top, so we have to put 3 times x minus 3. Then on our last fraction, it has both parts, so everything cancels as far as what we're multiplying by, but I still have to put the numerator, which is x minus 2. And now I'm ready to solve it like a normal equation. So I have to distribute here. Yep, 3x minus 9 equals, whoa. Add your like terms. X plus 3x is 4x. -3 minus 9 is -12. And then because there's not an x squared, we want our x's on one side and our numbers on the other. So I'm going to subtract x and add 12. So that I get 3x equals 10. Make sure that you remember, like this is something that we've done for a really long time. So make sure you remember you divide by what's in front of x. Because some of us get all the way to this point and then we screw up because we put like 3/10, which is backwards. You want to make sure you divide by what's in front of x, not the other number. So x equals 10/3. Now, if I come back up here to check and make sure it's really an answer, if I plug in 10/3 to any of my denominators, I'll get a number other than 0, so I'm fine. The numbers that wouldn't work would be 5 and 3. But that's not what I got. I got 10/3, so I'm okay.
It's not negative?
No, it's not negative. It is positive 10/3. Number 4. We need a common denominator, or we need to figure out what our common denominator would be. So first, let's factor this one right here. They have an x in common, so I'm going to put x plus 6, because if I take out x, I'm left with x plus 6, which is helpful because that shows us that all we need to multiply by is x times x plus 6, because that takes care of the first fraction, because that's the whole denominator, but also the x's will cancel on the second, the x plus 6's will cancel on the last one. So x times x plus 6 cancels, and I'm left with just this numerator. Oops. Now, you could factor the numerator here, but it's not helpful, like, because we're going to have to add like terms. So that's why I'm only factoring my denominators on this. The x's cancel on the next fraction, so I have to do x minus 1 times x plus 6, which means I have to FOIL, which I'll do in a little bit. And then the x plus 6's cancel out on the last fraction, so I have to do 6 times x. Now, I will admit this is kind of a doozy of a problem, but we're gonna see it through. we have to FOIL. So this first part isn't going to change because all I'm going to do is change this part right here. And if you FOIL incorrectly, obviously you'll get the problem wrong, so don't do that. Just a piece of advice from personal experience recently. Once we FOIL, we have a lot of like terms on the left side. 3x squared plus x squared is 4x squared. 3x, 6x, and negative 1x all add together to get 8x. Negative 6 and negative 6 is negative 12. And it equals 6x. So we're going to move the 6x over to the left side so that we can factor. Try to like go to the right. If you got some room over there. 8x minus 6x is 2x. Now, it's going to be helpful to us if we can take something out of all three of these. What number can we divide? All right, so we're going to take out a 2, which leaves us with 2x squared plus x minus 6. I'm going to scroll back up. Hang on. There we go. Now, that 2 that I took out, I can basically get rid of, because if I divide both sides by 2 and get rid of that 2, this will still be 0. That 2 would only matter if I had an x out there, and I don't. Now let's slide and divide to finish this off. I'm going to slide the 2 over here and get x squared plus x minus 12. What multiplies to get negative 12 and adds to get 1 would be plus 4 and minus 3. Since we slid, now we got to divide by 2. So x plus 4 divided by 2 is 2. And then this doesn't simplify, so we'd write it as 2x minus 3. Now we're ready to set those equal to 0 to get our two answers. X equals negative 2 and positive 3/2. If you need to write out that step where you set them equal to 0 and solve, be my guest. Go for it. Like x plus 2 equals 0, 2x minus 3 equals 0. Okay, so 5 and 6, we are setting up an equation. So what you need to remember is that if it doesn't say anything, or if it says jointly or directly, I don't know why all of a sudden my handwriting got terrible, but if it says jointly or directly, there isn't automatically a fraction. But if it says inversely, that's when we know that we definitely need a fraction. Yeah. So on 5, when it says y varies jointly with x, that means y equals, we have to have a k, and then x is going to be on top of our fraction. Because it also says inversely with the cube of z, so the z part of this is going to be on the bottom of our fraction. What exponent do I put whenever it's the cube of z? 3. And so this would be my answer.
Any questions?
Yeah?
Where do you get a K from?
There is always a K.
Always?
Yes. So on 6, when it says c varies inversely as d squared, there's a k on top because there's always a k on top. But since it's inversely, d squared goes on bottom. c equals k over d squared. Okay, so we're going to pick some letters here. Like we've got amount of money. I'm going to pick M for money. At a charity fundraiser is directly proportional to the number of attendees. So the other thing that's important here is the number of attendees. So I'm going to make that be A. So if it's directly proportional, directly means that it's not a fraction. So M equals KA, because there's always a K. Yes. Shh. Yes. Directly and jointly are the same. Jointly typically means that there is going to be more than one variable on the right side. Like when we have like a half BH, there's more than one thing. That's what jointly is for. So now we're going to plug in this first set of information they gave us. 5 attendees makes $100. So that means that K is 20.
Did 20 times 60.
What?
20 times 60.
So now we need to do 20 times 60. Because this is our formula now, and they told us to figure out how much it is for 60 attendees. So we got to do 20 times 60, which is $1,200. Identify the wholes and vertical asymptotes of each. Now the way we want to do this is we want to factor the top and the bottom of our fraction. X squared minus 1 factors into plus 1 and minus 1, because we have to think about what multiplies to get negative 1 that when I add together cancels out so that I don't have a middle term. So that's plus 1 and minus 1. Yeah, Ryan? Oh, okay, sorry, my bad, Ryan. On the bottom, what do they have in common that I can take out? 3. And that leaves me with x plus 2. Now, the reason we are factoring the top and the bottom is because if something cancels, that is a whole. Does anything cancel? No. So there is not a whole, so we would write none. We would not leave it blank. We would say that there is none. Leaving it blank implies that you have no idea what it means for a graph to have a hole. Saying none means that you know that there's not a hole there. Vertical asymptotes. You said the bottom equal to 0. That 3 doesn't matter because it doesn't have an x out there. So x plus 2 equals 0 at x equals negative. Because 3 equals 0 is not an equation. 3 equals 0. X plus 2 equals 0. That doesn't work. That doesn't give us an answer. But here I subtract 2 from both sides and I get x equals negative 2. Yeah, if it had 3x, then we would set that equal. So let's factor on number 9. What can I take out on top? Negative 3. And it is a good idea to take out the negative since they're both negative. Not just a good idea, I feel like it's actually pretty necessary to take out that negative. Now, x squared plus 2x minus 3, that factors into
X minus 1, x plus 3.
minus 1 and plus 3. Always check and make sure that you pick the right signs. Now, what cancels? Okay, so where x plus 3 equals 0 is a whole because we canceled out the x plus 3. Instead of it being a vertical asymptote, there is a whole at x equals negative 3. Hey, notice how I keep writing x equals and not just a number. That's kind of a big deal. I want you to actually put x equals or y equals. So if you don't, you could. Not all wrong. Like some wrong. I don't know what percentage wrong. I don't want to decide that right now. What we didn't cancel out on bottom is where the vertical asymptote is. So where x minus 1 equals 0 is our vertical asymptote. So that's at x equals positive 1.
Wait, why isn't it? Oh, because the negative 3.
The negative 3 on top just is chilling.
Wait, what about the 3 on the bottom? Oh.
This we canceled and it gave us a whole. Now in our notes, we had a chart that we talked about that when, and I don't remember what order it was in, but it said if x is has a bigger exponent on top, then it's none. So that would be this case right here. X squared over 2x. My exponent is bigger on top, so there is not a horizontal asymptote at all. If you graph this, it's going to look really weird compared to the other graphs that we did in this chapter. The next one, so number 11, what's happening is our exponent is smaller on top and bigger on bottom because there isn't an x on top at all. So if there's not an x on top, that's like there's an x to the 0. Shh. Stop having fun. Cut it out.
Don't cut that out.
X to the 0 over negative 4x. It's smaller on top, so this is when y equals 0 is our horizontal asymptote.
Okay, we do that again. Talk me through that.
Okay, so on top,
Okay, there's not an x.
there's not an x, so we're going to pretend it's x to the 0. And 0 is smaller than 1. On bottom, we have x to the first because of the negative 4x. So the smaller exponent is on top, and so it automatically is y equals 0.
Always the smaller one. So if it was like x like to the 1 on the top and x squared on bottom, would it be?
That would still be y equals 0 because the exponent on top is smaller than the exponent on bottom.
Okay.
Now, to me, the easiest one to remember is when they're the same. I have x squared on top, x squared on bottom, so I just take the numbers from the very front, 3 over 1, and I get y equals 3. Now, 13 through 17 on here is stuff from the first part of Chapter 9, our last test. And let me tell you, we need to factor first on all of these, okay? So in your head, just like chant, factor first, factor first, factor first, factor first. So on 13, what should I do?
Factor first.
Good job. Okay, so we can take a 3 out on bottom. These cancel. What does that mean my answer is? But it's 1 over 3 because the 3 was on bottom, so it doesn't magically get teleported to the top. It still has to be on the bottom of our fraction. We canceled everything from the top, so we put a 1 on top. Our restrictions are where the bottom equals 0. So I would do that after you factored because it's usually easier. X minus 5 equals 0 when x is 5. So x cannot be 5. Now, what should we do on 14?
Factor first.
Factor first. What? Factor first. Okay. So on bottom, they have a 4 in common that I can take out. Oh, okay. So let me warn you, by the way. I can see this happening to you on the test. Earlier, we cross-multiplied because there was an equal sign. The only time you cross-multiply is if there's an equal. If it's a multiplication symbol, it's not cross-multiplying. You're going to do this. Yeah, it's this way. The top and top, bottom and bottom. So, like, I can see some of us getting confused by that on the tests.
Can we take out the 4s?
Yeah, we'll cancel out those 4s here in a sec. Man, that red does not look that different than purple. Okay, let's factor m squared plus 6m plus 8. Plus 2 plus 4. And m minus 5 is on bottom. So the m plus 2's cancel and the 4's canceled. So everything went away on this first fraction. All I have left is m plus 4 over m minus 5. Remember, they've got to be the exact same to cancel out, so this is my answer. I don't somehow get negative 4/5. The m's don't go away. That's not how math works. Where would, what's our restrictions, guys?
0.
Not 0. 5 and negative 2. After you factor, look at your denominators. 5 and negative 2 are our problems. Hey, on 15? What should we do?
Multiply across. Factor first. Flip.
I like that you said factor first, but we actually don't have anything to factor,
Divide.
and it's dividing, so let's flip the fraction. So I guess in either case our abbreviation is FF. So that's kind of cool. Flip first. Flip fraction. Never mind. Shh. So flip the second fraction. Now a lot of stuff cancels here. Maybe not a lot. Some stuff cancels. The 14s can cancel. These p's can cancel. I can also simplify 20 over 12. It just depends on like some of us have problems simplifying ahead of time. And some of us like simplifying ahead of time. Like I could write this as 20 over 12p squared and then keep simplifying. We should get 5 over 4p squared.
I got 5 over 3.
5 over 3p squared. I was just testing you guys. 5 over 3p squared. That's our answer. And what can p not equal? 0. How'd I do what, Liam? Number 16. Now we're subtracting, which means we need common denominators. We do have common denominators, so let's just subtract a minus 4b minus 3a all over our common denominator. And then we've got like terms on top that we can put together. A and negative 3a. It's like having 1 apple minus 3 apples. You have negative 2 apples, whatever that means.
Did you owe somebody some apples?
Yeah, exactly.
How you gonna get into negative apples?
You eat some apples that aren't yours?
So now, the way we can check to see if this is able to be simplified is, can I divide everything by a number? Right, I can divide all 3 of these terms by something, which means that it simplifies. So I would divide them all by 2 and get negative a minus 2b over 2a to the 5th b. And what can a and b not equal? 0. Because I'm not adding or subtracting on bottom. I just have a to the 5th and b being multiplied together, so that's why they can't be 0. I don't have common denominators, so I need to think about what my common denominator would be. It has to have a 2, and it also has to have a p minus 2. So that's my common denominator. To make that happen, this first fraction needs a 2, and the second fraction needs p minus 2. So I do 2 times 5, which is 10, plus 1 times p minus 2, which is just p minus 2. So I add like terms on top and get p plus 8 over 2 times p minus 2. We can't because this doesn't have a 2. This p, since it's 1p, I'd have to be able to divide it by 2. So if that had been 2p plus 8, yes, we could simplify. But it's not. And our restriction is that p can't be positive 2. So we're finding all of this information for this problem. We can graph it, and that might help us. I don't actually mind, as long as if you want to graph it and look at it that way, that's fine with me. If we want to look at it algebraically, x squared over x cubed, the smaller exponent is on top, which means our horizontal asymptote is at y equals 0. From there, we need to factor the top and the bottom. And so that's what multiplies to get negative 3 and adds to get negative 2. Negative 3 and 1. Here, before we split into two parentheses, we need to take out the x that they all have. And then we can split it up into two parentheses. The reason we have to factor is because if something cancels, that's a whole. If it doesn't cancel, it's a vertical asymptote. So what multiplies to get negative 2 and adds to get negative 1 is negative 2 and positive 1. So does something cancel?
X?
The x plus 1's cancel. There's not just an x on top, so the x doesn't cancel. The x plus 1 cancels, which means there is a whole at x equals negative 1. To find the vertical asymptotes, we take the rest of what's on bottom and set it equal to 0. Because I did x plus 1 equals 0.
So, and put it to 0. But how did you do that if you canceled them out?
Because I said they canceled, but I still have to know where it equals 0. So x equals 0 and x equals positive 2 are our vertical asymptotes.
How did you get the horizontal asymptotes again?
You compare the exponents, x squared and x cubed, that chart. Yeah, none, 0, or something else. Now, 19 and 20, I believe, require the highest level of thinking as far as this test goes, because they're asking you to come up with a function that meets certain criteria. So this first one says it has to have a horizontal asymptote at y equals 0 and a hole in the graph. When do I have a hole in my graph? When something cancels. So let's start off by putting something on top that's the same on bottom, so it would cancel out. It doesn't matter what. I chose, when I did it, to do x minus 1 on top and bottom. Okay? That is how I get a hole, is by having something cancel. The way I get a horizontal asymptote at y equals 0, though, is to have a smaller exponent on top than on bottom. Right now, they're the same. So how do I make it so that there is a bigger exponent on bottom? I need to put like another x. So I could either just put x, or I could actually make it a whole other parentheses and put something else. What this means is there are a lot of different answers that you could choose, and I'm going to check your answer to make sure it qualifies. Okay? So you didn't all have to put this as the answer. That's just what I put on my review as my answer. 20, write a rational function that does not have a horizontal asymptote. When does something not have a horizontal asymptote? When it's bigger on top. So it doesn't matter what you put as long as it's bigger on top. So yeah, I put x cubed plus 1, and then I could put x squared or just x on bottom. And that would work. Divide by 3 to get our log by itself. And then change it to exponential. So we have to do 4 squared equals negative 4n. Divide both sides by negative 4.
Wait, whoa. Oh, okay.
Sorry, we're a little low on class time. The next 3 aren't going to take very long. But actually the last 4 won't take very long.
Oh, dang. Class flew by today.
So n equals negative 4. You can't divide by the negative 4 when we're up here and we have the logarithm, because the logarithm protects that negative 4n from us doing anything with it until we get rid of the logarithm, which we do by rewriting it as an exponential equation. All right, so identify as direct, inverse, or joint. Direct means that it's not a fraction. Joint means that there's going to be more than one variable. And inverse means it's on the bottom of the fraction. The x is not a fraction. It's not on the bottom of our fraction, so this is direct. We have more than one variable here, so this is joint. the variable's on the bottom here, so this is inverse.
So more than one variable
Is joint.
okay.
And 25, I think, should be easy. Like, you're just looking for where your horizontal or vertical asymptotes are. So our horizontal asymptote, remember, is y equals something, and it's this horizontal line at y equals 1. The vertical asymptote is the vertical line here at x equals 3. And I do want you to put y equals and x equals